If there's one thing that my grandfather taught me that I really wish I had learned by now, it's that age-old adage, measure twice, cut once. And that's why it's important to explore the vSphere environment in the VMware hands-on labs before we start making any changes to it. This will be a great chance to review those core elements that have to be in place before we start laying down any new networking components. So to get started with this lab, we're headed to VMware's HOL Online, and we're loading lab HOL 190301-net. I'm going to adjust my resolution and size, and then we're going to fire up Google Chrome. Once Chrome is opened up, let's log on as administrator at vSphere.local, and we'll use the vSphere lab password of VMware with a capital VM, 1 exclamation point, and then click Login. And I'm going to go ahead and head up to the upper right-hand corner and also adjust this to a full screen just to get the most real estate available. When the vSphere web client is showing us its homepage, we're ready to start navigating into the world of NSX. And of course, once NSX is installed and connected, we're going to find that under Networking and Security under the Home menu. So we'll navigate to that. And on the left-hand side, to really verify that we have the right environment, we should head over to Installation and Upgrade, which is where the core components are going to be found. We can see our manager, and of course, without a connected manager, we wouldn't have anything that we're seeing right here. On the subnode here, let's head over to NSX controller nodes. When we head over to the NSX controller nodes, you might notice that there's one controller, and you might be scratching your head saying to yourself, wait a minute, I thought Jacob said in some other nugget at some other time that there should be 3 controller nodes, and there should be. There's only one controller node that's been installed so far, and that is to alleviate the utilization of resources in this limited lab environment. Real world, yes, 3 is the magic number. It's what you're looking for and what you would expect to see right here, so that if one goes down, there can still be load balancing and failover support. Quick reminder, what's the point of the controller node? It is the central point where our hosts can find the MAC addresses and IP addresses and VTEP endpoints of the ESXi hosts that are going to provide tunnel communication. So the controller node is going to be the information board so that all the hosts have the information they need to forward frames in VXLAN tunnels appropriately. So let's head up to host preparation, see how those hosts are doing. Hosts get prepared a cluster at a time, and we can see that there are 3 prepared clusters, a Comp 1, Comp 2, and Management 1, and we see green check marks all over the place saying, yep, looks like they're good. But let's investigate just a little bit further. Here on Region A, Compute Cluster 1, and Compute Cluster meaning it's going to hold end-user related VMs, not infrastructure VMs that are supporting NSX itself, for example. We can see our version. We can see that we're already set up with support for the firewall and for the VXLAN itself. If we go to View Configuration under VXLAN, so for this cluster, as far as VXLANs are concerned, we have a common virtual distributed switch, remember not a standard switch, but a vSphere distributed switch that supports the tunnel endpoints. No VLAN was needed because our network infrastructure evidently is not using VLANs, but we do need to have the larger than default MTU of at least 1600, and the endpoints are all going to get IP addresses based upon an IP pool that's been configured that'll make sure that they can all talk to each other within this cluster. If we actually take a look at those nodes, we'll close that up. Let's head over down to ESX1 and click View Details. And we can see, okay, so ESX1 has a VMK number 3, which is on that distributed switch. That's what's implied here because it got an IP address that allows it to participate in this VXLAN tunneling communication. Perfect. If we click on View Details for ESX2, we can see, oh look, 130.52. Under communication channels, good to see this as well. Let's click the first up on ESXi-01. What are the communication components? Well, we need to make sure that the manager can actually connect to the firewall agent on the host. We need to make sure that the manager can connect to the control plane agent of the host. And we need to make sure that the control plane agent can contact the controller, or rather really that control cluster, because it's going to be that control cluster that provides the central information of ARP tables, MAC tables, and VTEP tables necessary to forward information. So all of those are up. That's excellent to see. Let's keep digging into our infrastructure. Up at the top, let's head over to Logical Network Settings. Under Logical Network Settings, we can see that the VXLAN port that's been configured is 4789. That's the default VXLAN port. If that was changed, we would need to adjust, of course, how our firewalls allow for traffic to go in and out. But that's the default here. Under the segment ID pool, we see the range of 5,000 to 5999. This is going to be the pool that will be used when setting up VXLAN network identifier, VNIs. So they call them segment IDs here. They're going to be called VNIs here. Every time we create a new logical switch that is based upon the VXLAN technology, it's going to have to dip into that pool and be assigned some number that comes from it. So great, we can see the numbers, we'll be able to recognize them, and you'll notice that they are set up to not overlap even a little bit with VLAN numbers. Perfect. You'll notice multicast addresses is empty, and if we go to edit on that segment IDs, we can actually turn on multicast addressing, and then we need to specify the range of multicast addresses that can be used in order to coordinate information. So multicast addresses are used if we're working with multicast or a hybrid approach to enlightening hosts about ARP tables, MAC tables, and VTEP tables. But if we are using the new standard default unicast communication, which is based upon using the central control cluster, then we're not multicasting and no addresses are needed. So that's why this is left off by default, because the expectation is that we're communicating with the cluster. And that's how we're going to be working in this particular lab environment. Real world, you may want to set up that pool of addresses and start having multicast communication. But that requires your physical infrastructure play nicely with your virtualized infrastructure, right? We got to support multicasting on the physical network for that to be conveyed correctly. So for now, we'll just cancel out of the segment ID settings. And up at the top, let's head to transport zones. The transport zones are where we usually define how we're actually going to work here. Now, there's not a lot to set here. If we click the radio button next to our default transport zone, region A0 global TZ for transport zone, and we click edit, we can see that really there's a name, a description, and as promised, the communication methodology of unicast, which is the default selected. So if we needed to switch to multicast or hybrid, we certainly could do that here. There are some advantages in terms of traffic and communication. Unicast is actually relatively noisy because we got to keep going back and forth to the cluster, where multicasting has some efficiencies that are a part of it, but require the physical network to be configured for multicast. Let's cancel out of this. Now under the scope, you might notice this is a global transport zone. That means that it will only function under the jurisdiction of one vCenter server. Now the other type of transport zone that could be built is a universal transport zone, which supports cross vCenter communication, but that would require that we only use universal logical switches to support that communication. Now to see which clusters are participating in this specific transport zone, we could click Connect Clusters. And we can see that we currently have 3 clusters, and they're all checked on the left-hand side, and they all have normal status. If a cluster was missing, we would need to add it here. If a cluster doesn't belong here because it's never going to use those VXLAN components, then we could cancel out of here and disconnect it. Let's actually, instead of selecting the radio button, actually click on the link to the transport zone. And this digs us a little bit deeper into a nested region where we can actually see the list of all their clusters and see their configured MTUs, VLANs, NIC assignments, their details of their IP addresses. So some of the stuff that we saw at the host preparation level, but now we're seeing it relative to the transport zone. Also, we can see the list of logical switches. So there's 8 logical switches that have already been created for this lab environment. We, of course, will be building our own switches and getting them configured to work correctly. But this is great because we have some examples of things that are already set up and can work for us that are there to support different types of networking. However, you'll notice that none of these are able to be edited in this location. If we actually want to edit logical switches, or dare we say in our next nugget, build some logical switches, then we're going to need to head over here to the actual logical switches node rather than viewing logical switches as objects that are a part of this particular region. Usually, everything just cross-links to full edit level, but in this case, it doesn't. So let's select logical switches on the left-hand side, and we'll see a very similar looking list. Right there, there are the names of those same logical switches. And at this point, let's just notice that each of these switches has their own segment ID, or VNI. And over here on the right-hand side, we can see, for example, that the Windows tier has 2 VMs actually running on that particular logical switch. Web tier has 2, the transit network has 0, the database tier has 1, the collapsed logical switch has 6, so on and so forth. Well, my friend, we took our time to take a look at our lab environment to get the lay of the land, because before we start making changes and configuring things, we need to know what our baseline looks like here. And I'm sure that neither you nor I would want to walk into someone's network or have someone walk into our network and start making changes without at first seeing what already exists, how things are connected, and definitely don't attempt to build anything new before you've fixed any problems with what's already in place. With that said, if you're going to be continuing on to the next hands-on lab, feel free to leave your lab environment up and running, and you'll be able to jump into the next lab that much faster. I hope this has been informative for you, and I'd like to thank you for viewing.